Okay, class, what do you do when you hear the nuclear bomb siren?
Run and hide.
Yeah. No, you duck and cover.
What are nuclear bombs?
Okay, instead of learning today's lesson, we're going to learn about nuclear bombs.
Yay!
Oh.
Hi, today we are here to talk to you about nuclear warfare, and especially nuclear fission and the Manhattan Project. This project is by Nour Zarrouk, Gabby and Justin Bacon. What is a nuclear bomb? Nuclear bombs are weapons of mass destruction. They harness the forces, strong and weak, that hold the nucleus of an atom together, especially atoms with unstable nuclei, by using the energy released when the particles of the nucleus, neutrons and protons, are either split or merged. Nuclear fission. As we learned in class, an atom consists of 3 subatomic particles: protons, neutrons, and electrons. We also learned that the center of an atom, the nucleus, contains positively charged protons and then neutrons that don't have any electric charge, and that all atoms of the same element have the same number of protons, but the number of neutrons can vary. The nuclei of some radioactive elements can split, which is called fission, if bombarded with fast-moving neutrons. The split of the nucleus can make into 2 smaller fragments with a neutron, as you can see in the diagram below. Nuclear fission releases energy in the form of heat and light from the atom. Radioactive decay. In nuclear fission, large amounts of heat, energy, and radiation are given off. The most atomic nuclei are stable, but a few aren't stable. These nuclei produce and discharge particles known as radiation. A nucleus that emits radiation is radioactive, and the act of emitting particles is known as radioactive decay. There are 3 types of radioactive decay: alpha decay, beta decay, and spontaneous fission. In alpha decay, a nucleus ejects 2 protons and 2 neutrons bound together, known as an alpha particle. In beta decay, a neutron becomes a proton, an electron, and an antineutron. The electrons ejected is the beta particle. In spontaneous fission, a nucleus splits into 2 pieces. In the process, it can eject neutrons, which can become neutron rays. The nucleus can also emit a burst of electromagnetic energy, known as a gamma ray. Gamma rays are the only type of nuclear radiation that comes from energy instead of fast-moving particles. Certain isotopes of radioactive elements such as plutonium-239 or uranium-235 can release 2 neutrons when they fission. Then these two secondary neutrons collide with each other with nearby nuclei, causing them to fission and release 2 more neutrons. Each fission reaction doubles the amount of neutrons and energy released, causing a chain reaction. After a few microseconds, the chain reaction produces an explosion equivalent to an explosion of thousands of tons of TNT. The atomic bombs dropped on Hiroshima and Nagasaki, Japan in 1945 were fission-based. Those explosions were equivalent to about 15 and 20 kilotons of TNT. Similar controlled fission processes generate the energy in nuclear reactors. Even though our project is mostly based on nuclear fission, we will go a little bit over nuclear fusion since it's a part of nuclear warfare. There are 2 basic ways that nuclear energy can be released from an atom: in nuclear fission and nuclear fusion. Nuclear fusion brings together 2 smaller atoms, usually hydrogen or hydrogen isotopes, to form 1 larger one, usually helium isotopes. In nuclear fusion, large amounts of heat, energy, and radiation are given off as well. Fusion occurs when the nuclei of 2 atoms combine to form a single heavier atom. At extremely high temperatures, the nuclei of a hydrogen isotope, uranium and tritium, can readily fuse, releasing enormous amounts of energy in the process. Fusion bombs have a higher kiloton yield and greater efficiency than fission bombs, but they can present many problems. The fission bomb is used to spark the fusion bombs. The atomic bomb uses nuclear fission, and the hydrogen bomb, as also known as fusion bombs or thermonuclear bombs, uses nuclear fusion. And this is a diagram of the nuclear fusion. As you can see, the deuterium collides with a tritium, and releases helium and a neutron, because there's like one extra right here, and it releases energy.
Hello, today I'm going to be talking to you about nuclear bombs, and more specifically, how they are made. When the Manhattan Project started in the late 1930s, the scientists hired by the U.S. government were trying to make the U.S. nuclear program more effective. Towards the end of World War II, the U.S. government decided that they would have to use a nuclear bomb to destroy Japan for no extra American casualties. To do this, they had to find two key resources, and they decided to use uranium and plutonium. Uranium is not the same as uranium-235. The scientists decided that they had to enrich uranium so that it could be more effective. And they had to increase the nucleus and add more weight to the uranium, and they found out this would be uranium-235. They had to do the same for plutonium, and this is plutonium-239. For plutonium, they had to use a reactor to increase its concentration. As you can see on the screen here, this is Fat Man. This was a plutonium-based bomb that was used on the bombing of Nagasaki. The design of Little Boy. Little Boy was another bomb that was uranium-based that would be detonated over Hiroshima. The dimensions for this bomb was to have a bullet design, and here are the dimensions. 86 pounds, 7 inches long, with a diameter of 6.25 inches, with an inside diameter of 6.5 inches. This would allow the reaction to start quicker on impact. The design of the bomb. The final steps of the bomb were putting in the fuse system so that when it was detonated, it would explode. Nobody wanted to do this because this was very hard to do and it was very risky. 3 stages that were used for this: a timer that would not explode until 15 seconds until it was released, a barometric which would not explode until a certain altitude, and then a radar which will tell when the bomb can be exploded. Here's the design of the bomb. As you can see on the screen here, that there are a bunch of key components that were used for this bomb. And that's pretty much it. And this is pretty much how nuclear bombs are made. They are very dangerous to make, and that they have specially trained people to make this. I hope this was very informational to you guys.
How nuclear bombs affect us. Nuclear bombs, when exploded, have a heat of 4,000 degrees, which would vaporize all the people in buildings in the immediate area, and would make a crater at least 100 meters in diameter. The number of deaths from radiation sickness is quite high. In the immediate area of the nuclear detonation, this compares to the temperature inside the core of the sun. How nuclear bombs affect the environment. A small-scale war would quickly devastate the world's climate and ecosystem. This would cause damage that would last far more than a decade. The ozone layer would be depleted by 40% over many inhabited areas and up to 70% at the poles. The production of nuclear weapons has polluted vast amounts of soil and water. Testing of the nuclear bomb has been the most destructive of the environment. Underground tests have contaminated soil and groundwater.
I hope you enjoyed the video and learned many things from it. To learn more or to listen to our interview, copy the link below. And thanks for watching.
Go.
Okay, just stop. Alright, just like not. Nuclear Warfare and Nuclear Fission and the Manhattan Project by Nour, Zarrouk, Justin Bacon, and Gabby Morris. Nuclear bombs. Nuclear bombs are weapons of mass destruction.
Oh my God.